So today's session is about polynomials, the topic of polynomials which we're going to introduce in today's session. So what are polynomials in general? What is the word polynomial in mathematics is the biggest question in the introduction. So when you come to polynomials, before we discuss the actual definition in mathematics, let's come with how the existence of polynomials came into consideration in the field of mathematics. So when it comes, say for example, I have a rectangle with dimensions, length being x and the width being x minus 4, and this area is 24 meters square. Now, when the area of the rectangle is given to be 24 meters squared and my length is x meters and my width is x minus 4 meters, then I can derive a polynomial out of this situation in mathematics. Let's see how we can derive a polynomial or an expression out of the given conditions. Now, immediately when I see this, I see that this is a rectangle, and hence the area of the rectangle given to be A equals 24 meters square implies area is length into width. Therefore, I have my area, which is length times width equals 24, is how I understand this problem for the given area and the given dimensions. So when I simplify this more further, I see that x times of x, which is x squared minus 4x, is equal to 24, is how I get when I further simplify the previous statement. Now therefore, in this case, I get x squared minus 4x minus 24 equal to 0. So these kind of equations we commonly get in various problems which we solve in mathematics, not only in the problem related to areas of rectangles, but many situational problems related to the topics of mathematics where we come across these kind of expressions in daily life solving of math problems. So these kind of expressions are nothing but called the polynomials, which we are going to study in today's session in brief. So why do we call this a polynomial, or what is the exact definition of a polynomial defined in mathematics is what we discuss in the session. So to start with the definition of a polynomial, we start with the definition which says a polynomial is an algebraic expression which is constructed using variables and constants. So variables are the one which can be changed according to the value you fix in there, but constants are the values which are fixed but do not change with the changing value of the variable. So a polynomial is an algebraic expression which is constructed using variables and constants. Therefore, if I see a polynomial, for example, is 3x squared, 4x squared minus 2x plus 2 by 3x cubed plus x minus 1 are all examples of polynomials, is how we understand the polynomials in general. But you have some restrictions because in each of the cases the powers of the variables are integers, are the positive integers or the non-negative integers, but they are not fractions. So to define this more into a more transparent definition of understanding the polynomials, we try to discuss about the polynomials in single variable, that is x, in this session of the topic. So when I discuss about polynomial, in one variables, These all are the polynomials in one variable, that is x. We call this 3 as polynomials in one variable x because you identify only one unknown, that is x, which is the variable. So polynomials in one variable x are generally in this form. So let's see in brief on how we define a polynomial in single variable x in its own general form. Now, a polynomial in one variable is generally an expression which is denoted with Pn of x. A polynomial in one variable is generally denoted by Pn of x, and it is defined as an algebraic expression which consists of the constants and variables in this form. So this is how we define a polynomial in one variable x consisting of n plus 1 terms in this. So this polynomial in one single variable with each of the constants a0, a1, a2 and a3 till an make a defined polynomial in one variable, where a0, a1, a2 till an are called real coefficients, because for a polynomial to be defined, the coefficients cannot be complex. I cannot have ix or 3i plus 4i x square, etc., because an imaginary numbers or the complex numbers do not come into existence. The restriction of a definition of a polynomial is that each of the constants are called real coefficients. And in this case, an is not equal to 0, is how we understand, because if an is equal to 0, then I have the whole of this polynomial reducing by 1 degree. That is, this is called a polynomial of degree n. Of degree n, that is, the degree decides that an is not equal to 0. If an is equal to 0, the whole of the x power n vanishes, and then the highest power here is n minus 1. Therefore, this cannot be a polynomial of degree n minus 1, because degree of a polynomial is the highest power to which the polynomial is raised, is how we understand. So therefore, let's understand this to be a polynomial of degree n, where each are real coefficients, and there are certain things I need to note here. The first thing is each power of x, as I see here, power 1, 2, 3, 4 till n are all non-negative integers, but they are not fractions. Each power of x in each term of Pnx is a non-negative integer. The powers cannot be negative or cannot be fractions, is how I understand the first point. And secondly, I understand that a0 is the only term independent of x. Each of the terms are having x in its term. That is, if I take the second term, I have x in this. If I take the second last term, I have x in this. But the specialty of the first term is that it is a constant term, is the only term independent of x, and hence this is called the constant term, is how we understand the constant term. So these are the different structures through which we define a polynomial in single variable x. So let's recap with how we define a polynomial in single variable x. A polynomial generally denoted by Pnx is written in the form a0 plus a1x plus a2x squared so on till anx power n is called a polynomial of degree n because the highest power of this is n, then where each of the coefficients a0, a1, a2 until an are called real coefficients, and then an is not equal to 0. Together make a polynomial of degree n. Let's see some example problems and identify whether the given algebraic expression is a polynomial or not a polynomial. If it is a polynomial, we also need to identify the degree of that polynomial. So let's see some example problems.